The program that we will write this time is very interesting. It is calculating the sum of fractions. I repeat, calculating the sum of fractions. The sum of fractions. Now, what is this? Sum of fractions means, you can understand very well, I want to calculate 2 by 3 plus 3 by 4 plus maybe 3 by 5 plus 2 by 9 and so on. I want to calculate what is the result of this. So, the first question that comes to your mind is, how will I represent 2 by 3? Is it a floating point number? I want to represent it as a floating point number? No. I want to represent it as a fraction, and also I want the sum to be a fraction. So, first question that comes to your mind is, how to represent this fraction? 2/3, if I say it is 0.67, you can easily put it in an array element 0.67, but 2 by 3, how will you put it? We will represent it using two arrays. Say suppose user has wanted 2/3 plus 3/4 plus 3/5 plus 2/9. In that case, you will take an array A, and in that array you will enter only the numerators. That is, see, 2 is a numerator, next fraction 3 is a numerator, next fraction 3 is a numerator, next fraction 2 is a numerator, 2/3, 3/4, 3/5, 2/9. How? See, 2 is a numerator, next fraction 3 is a numerator, next fraction 3 is a numerator, next fraction 2 is a numerator. I will put the denominators in another array B, and the denominators are 3, 4, 5, 9. Check out what? The denominators I will put in another array, 3, then 4, then 5, then 9, then 9. These numbers I will put in another array B. So, A and B togetherly will be representing the fractions. So, see, the fractions will indicate this 2/3, 3/4, that is 3 by 4, then 3 by 5, then 2 by 9. So, AI divided by BI is the fraction. AI by BI, see, A0 by B0, 2/3, 2 by 3. A1 by B1, 3 by 4. A2 by B2, 3 by 5. A3 by B3, 2 by 9, and so on. So, this is how you represent the fractions. Question is, how then you calculate the sum of the fraction? For that, if you remember, what we used to do was, in the denominator, I used to always put, calculating the sum of fractions, we always used to put the LCM of the denominators. You remember? 3, then 4, then 5, then 9. What will be the LCM? LCM of 3, 4, 5 and 9, what are they? Say 9 into 5, 45. No, 45 will not occur because 2 is not there. But 9 into 10, 90. 90 is a possibility. See, 90 is divisible by 9, divisible by 5, not divisible by 4, not divisible by 3. So, 90 is still not your answer. So, 180 can be the denominator. See, 180 is divisible by 9, 180 is divisible by 5, 180 is divisible by 4, yes, it is divisible by 4, and finally 180 is divisible by 3. So, we used to put the LCM of the denominators in the denominator, and then what? We used to do 180 by 3, that is 60 into 2, 120, that is 2/3 will mean 120 by 180. Then plus, you remember all the numerators in terms of this ratio of this 120 will be used. So, 120 plus what? See, 180 divided by 4 is 45. 45 into 3 is 135. So, 120 plus 135 plus what? See how I get 135? 180 divided by 4, 45 into 3, 135. That is how you add fractions. Then 180 divided by 5. 180 divided by 5, what is that? 36. 36 into 3, what is that? 108. So this is 108 plus. Then again, 180 divided by 9 is 20. 20 into 2 is 40. So this is 40. And this is the total fraction. So you can say the sum of the fraction is equal to 120 plus 135, that is 255, plus 100 is 355, plus 8 is 363, plus 40 is 403. So the sum is 403 divided by 180. I repeat, how 403? 180 plus 40, 148, plus 100, 248, plus 30, 278, plus 5, 278 plus 5 is 283, 283 plus 100 is 383, plus 20 is 403. So 403 by 180 is the answer. So you understand how I do it? So firstly I will need to do the LCM of the denominators. Then that means LCM of the B array numbers, that is the numbers in the array B, I will need to calculate the LCM of the elements of B. Once I get the LCM of the elements of B, what I will do is, I will divide this LCM by all the elements, an individual element of B, that is Bi. I will divide the LCM by Bi and multiply it by Ai. Check out what? This is A, 2, 3, 3, 2, 2, these are A. So I will divide the LCM. Firstly, I will find the LCM of the elements of B. 3, 4, 5, 9, I will find the LCM. I know how to do it. Then I will divide the LCM by B0 and multiply it by A0. Then I will divide the LCM by B1 and multiply it by A1. I will divide the LCM by A2 and multiply it by A2, LCM by B2 and multiply it by A2. And every time whatever I get as a result, I will have to keep on adding with sum to get the numerator. Understand? And the denominator will be the LCM itself. So I repeat, LCM of 3459. What is the LCM of 3459? LCM of 3459 is 180. How I am doing it, I am trying to explain you. I will firstly find the LCM of the denominators, that is the LCM of the elements of B. Once I do the LCM of the elements of B, I will divide this LCM by one individual element of B, 3, 60. And then I will multiply it with the same element of A, that is with 2. 60 into 2 is 120. So you understand how? I have divided 180 by B0 and multiplied it, 180 by 3 is 60, and multiplied it by A0, that is it becomes 120. Then I will add this 120 with what? I will again divide 180 by B1 and then multiply it by A1. 180 by B1 is 45, into 3 is 135. So I will multiply it by A1 and make it 135 and add. Similarly, I will continue like this. So every time for all i's, I will divide the LCM by Bi and multiply it by Ai and add to get the sum of the numerators. This is how the program is done. So the first thing that you do is enter the fraction. Over here, this program is the basic program to get the elements of one array. Here I will write enter the number of fractions. I will need how many arrays over here? 2 arrays. A to contain all the numerators and B to contain all the denominators. So An and Bn. So here I will write not the enter the number of elements but enter the number of fractions. Enter the number of fractions. So I will get the number of fractions again in n. Now I will say enter the %d fractions. User will enter the fractions one by one. Remember, for your help, user will never enter this 2. User will never enter like this 2, then 3, then 3, then 2. User will not enter like this. User will enter 2, then 3, then 3, then 4, then 3, then 5, then 2, then 9. That means I will have to scan one number within the A array, then the next number in the B array. Again the next number in the A array, next number in the B array. So firstly I need to scan A0, then B0, then A1, then B1, then A2, then B2 and so on. So I tell the user exactly the same thing, enter the %d fractions one by one. Now you write, you explain the whole thing to the user. For each fraction, firstly enter its numerator, then enter its denominator. Firstly enter its numerator, then enter its denominator. So this is what you tell the user, followed by followed by the next fraction in the same way. Next fraction in the same way. So see what I have written for the user. I have helped the user by saying that enter the fractions, enter the percent d fractions. Percent d means this n. This percent d will be replaced by n. User has told this many fractions he will enter. Enter the percent d fractions one by one. For each fraction, firstly enter its numerator. That is, if user has to enter 2/3, firstly enter 2. Then enter its denominator. That is, then enter 3. Followed by the next fraction in the same way. That is, if he wants to enter 3/5 now, firstly 3, then 5. Followed by this n I have written to replace the percent d. So now what? Once this has been told to the user, remember user will now keep on entering the numerator followed by the denominator. So I will have to scan. How to scan? See, user will actually enter 2n integers, because for n fractions, one numerator, one denominator. So firstly you scan A0. A0 means you scan the first numerator. Then you must scan B0. Then you must scan B0. Is not it so? You scan B0 means what happens as a result? The denominator, the first denominator is scanned. Then it will go back, I will become I++, that is I will become 1. It will scan A1 followed by B1. That's what you want. Firstly A0, then B0. A0 is the numerator, B0 is its denominator. Then A1, then B1. A1 is the numerator, B1 is the denominator. Next A2, then B2. A2 is the numerator, B2 is the denominator. This is how you scan all the fractions. Now remember, once the fraction has been scanned, now what do you need to do? LCM of the denominators. Is not it so? LCM of the denominators, that is LCM of the elements of B array. How do you calculate the LCM of B array? For that, firstly what you do is you do the max. So first for that is maximum number, max of elements of B array. First you calculate the maximum, then only LCM is possible. If you remember LCM, we had done it earlier. So let us do it very easily. For I equal to 0, I less than n, I plus plus, if AI, or not AI, BI, I am calculating for B. If BI greater than max, then what? Max equal to BI. So this is how you get the max. Once you go out of this for loop, you know max contains the maximum element, but the max must be initialized. So for I equal to 0, max equal to 0. Initialize the max, but don't you forget to also declare max. Do that declaration. So you have found the max. Now the LCM. So next for loop should calculate the LCM. Is not it so? So next for loop calculates the LCM. How to calculate LCM? Remember, for the LCM, I will go by factor. If you remember how to calculate LCM, if you remember, I will keep on multiplying the maximum element by different factors starting from 1, and every time I will consider that LCM, this is the LCM itself, that is LCM, a variable called LCM is equal to max into factor. Firstly max into 1, I will check whether this is the LCM. How? I will check whether this is the LCM. How? For all elements I equal to 0, I less than n, I plus plus, I will check if LCM is divisible by BI or not. If it is not divisible for any, then I can immediately say that it is not the LCM. So let us initialize a flag at the beginning, make it 1. If it is not divisible, I immediately understand this is not the LCM. I make flag equal to 0 and break out. You remember this? If you come out of this inner for loop with flag equal to 0, you know that you have not got the LCM, you should continue. But if flag is equal to 1 again, you had initialized it to 1. If you come out with 1, it means it could not enter here. That is, it was divisible for all elements of the array. So flag remained 1. So if flag is equal to 1, what will I do? I will break out. I understand I have got the LCM. It was divisible for all BIs. That is why it could not enter. That is why flag is still 1. That means now I have got the LCM. Otherwise, I will again multiply max by the next number and check whether that is the LCM or not. So here I reach min. I have got the LCM of the B array. Now, before you continue with the next part, let us declare every variable that I have used. Firstly, I have used the factor variable. I have used the LCM variable. I have used the LCM variable. I have used the flag variable. So all variables I declare over here. Next, I continue. How do I continue once I got the LCM? Next, I will say for all fractions, divide LCM by denominator. Divide LCM by denominator. That is what I was doing. Divide LCM by denominator and multiply by respective numerator, which means that for all fractions divide LCM by BI. So for all fractions means for all i's, for all I from 0 to n minus 1. For all I from 0 to n minus 1, divide LCM by BI, that is denominator, and multiply by AI, the corresponding AI. Then only you get it. Okay? All results to be added to sum. Is not so? All results to be added to sum. So how to do that? Very simple. So for all I you need to do, for all I from 0 to n minus 1 you need to do that. So you do that same thing for I equal to 0, I less than n, I plus plus, I less than n, I plus plus. What to do? What to do? I need to initialize a sum to 0. Don't forget, every time whatever I get, I need to add it to sum. Sum is equal to sum plus, or else you can write sum plus equal to what? LCM divided by BI. Remember, it will be exactly divisible. Why? Because LCM, you have done it that way only. LCM means it will be divisible by all the numbers. That is the definition. So AI will be multiplied with that. LCM divided by BI, AI to be multiplied with that added to sum is the sum of numerators. Is not so? So what is this sum? Sum of numerator. You can rename this variable as sum of numerator. I just give it a big name. The variable has been renamed as sum of numerator. And what is the denominator? Denominator is the LCM itself. If you remember, LCM was this denominator. Here I had shown you. The LCM itself is the denominator. So LCM contains the denominator itself. However, the sum of numerator has been calculated this way. Once you have got that, you can print it to get the final sum of fractions. What will be the numerator? Numerator will be the sum of numerator variable. What will be the denominator? Denominator will be the LCM variable. So printf, the sum of fractions is %d, that is the numerator, by %d, the denominator. Is not it so? So the first %d is the numerator. Where is it contained? Sum of numerator variable, comma, where is the denominator? In the LCM. So here you have got the sum of fractions. One variable you have not declared still. What is that? The sum of numerator variable. Sum of numerator. This is how you have named the variable for understanding purpose. Somebody sees your program later, will be able to understand what you mean. That's why. So let me run this program and check what happens. Alter, oh okay, one thing, you must comment out the upper portion. Yes, this portion must be commented out. So comment out this portion. Now run this. Alter, enter. No errors, enter the number of fractions. Say 3 fractions. Enter the 3 fractions one by one. For each fraction, firstly enter its numerator, then enter its denominator, followed by the next fraction in the same way. So the 3 fractions are 2/3, 3/4 and half. 2/3, 3/4, half. Let's see what's the sum. The sum is 23 by 12. Check out how. 2/3, 3/4, half. So 2/3, 3/4, half means the common thing is 12. See, numerators are 3, 4 and 2. So out of 3, 4 and 2, what will be the LCM? 12. So 12, 2/3 means 8 by 12. Is not it so? 2/3 is nothing but 8 by 12. 3/4 is nothing but 9 by 12. So 8 by 12, 9 by 12 and half is 6 by 12. So 8 by 12 plus 9 by 12 plus 6 by 12. 8 plus 9 plus 6. That is 23. So it's 23 by 12. The sum of fractions is 23 by 12. I think you have understood this code. I will leave this over here with a bit of work for you to do. See, the sum could have been 24 by 12 also. Not only 23 by 12, but it could have been 24 by 12 also. On the contrary, it could have been 12 by 24 also. Now, if it is 24 by 12, instead of writing the sum is 24 by 12, it would have been better for you to write the sum is 2. However, if it is 23 by 12, then you need to write 23 by 12. But if it would have been 24 by 12, it is better to write the sum is 2. How to do that? Similarly, if the sum was 12 by 24, it is better to write that the sum is half. How to do that? If the sum would have come to 6 by 9, it is better to write that the sum is 2 by 3. How to do that? I will leave it for you over here, asking you the question how to do it. I will not solve it. It is your task to solve. I give you the hint. The hint is, out of 2, if it is 6 by 9, it is better, if the sum is 6 by 9, it is better to write 2 by 3. How will you know that? 6 and 9, what is the HCF of 6 and 9? It is 3. Divide 6 and 9 both by its HCF, you get 2 by 3. 24 by 12, what is the HCF? HCF is 24 and 12, what is the HCF of 24 and 12? 12. Divide 24 by 12, it is 2. Divide 12 by 12, it is 1, so it is 2 by 1. Change it to 2. If it is 12 by 24, similarly it will become half. So you need to find the HCF of the numerator and the denominator and then divide both of them by the HCF to get the smaller fraction. However, without that constraint, this program runs fine. I will request all of you to run this program again, check this program again and write it yourself again. Thank you so much. Let us take a bit of break and come back.